Thank you very much. So, as I was introduced there, my name is LShannon, and I've been working on the project since 2005. And I'm just going to give you guys an overview of the geology and mineralization of the Pebble project. How do I advance this? Okay. So we'll start with introduction, a little bit about exploration, the regional geology of Alaska, regional geology of the mine study area itself, the bedrock geology, alteration, the deposit structure, deposit geology and mineralization, a little bit about the mineral resource estimate, other mineralized zones around the deposit, and the superficial geology study that's been done, and superficial geology of the project area. So the geology of the Cook Inlet area is not covered in this presentation because most of the baseline studies have been completed in the deposit area. And most information in this presentation is sourced from internal Northern Dynasty Mines and Pebble Limited Partnership documents and other published information. So exploration at the has outlined a copper, gold, molybdenum-rich, hydrothermally altered porphyry system surrounded by an IP anomaly, which is induced polarization, covering an area of 90 kilometers squared in southwest Alaska. The exploration has been going on since 1985, and that has delineated the Pebble deposit itself and other mineralization zones surrounding it. And all of these deposits are associated with a multi-phase late Cretaceous intrusive complex. So, who's been conducting the exploration from 1985 to 1997? Most of it was done by Caminco Exploration. Then Northern Dynasty Mines took over from 2001 to 2007, and the Pebble Limited Partnership from mid-2007 to present. Things they've included in their exploration programs are geological mapping and geophysical surveys, including induced polarization, electromagnetic methods, and magnetometer. They've done soil sampling programs and diamond drilling. So the overburden and weathered bedrock in exploration drilling is typically triconed. The core is boxed and depth markers are inserted at the drill. Then all core is shipped back to Iliamna and logged by POP geologists and technicians in a core shack. And there they look at the rock type, alteration, veins, mineralization, structure, and record geotechnical data. And all the core is photographed before it is cut and sampled. So assay samples are taken at 10-foot intervals in the Cretaceous rock where there's higher mineral potential, and 20-foot intervals in the tertiary rock. And the samples are analyzed by ALS Minerals, formerly ALS Chemics Laboratory. And they're analyzed mostly for gold, copper, molybdenum, and 23 other elements. And there's quality control protocols in place that meet the 43101 industry standard. And that's just a sample of the core box there at the bottom. So the regional geology of Alaska consists of an assemblage of northeast trending crustal blocks or terrains that amalgamated due to subduction beginning in the late Paleozoic. And the star on the figure there is where the Pebble project is located within those terrains. So it's located in the Kalhitna terrain. The regional geology is located in the northern circum-Pacific orogenic belt the complex structural setting created by tectonic plates converging. And as I said, the study area lies within the Kalhitna terrain, just northwest of the contact with the peninsular terrain. And the regional structure is broadly defined by northeast-southwest trending faults that are related to translational motion. The Kalhitna terrain is a basin filled by Jurassic to Cretaceous volcanic and sedimentary rocks. These rocks were intruded during the Cretaceous by compositionally variable stocks, dikes, sills, and other intrusive bodies, and 90-million-year-old plutonic rocks such as the Kaskenak batholith. And all these rocks are host to the pebble deposit and other mineral showings in the area. The region has been subjected to extensive erosion and deposition of tertiary sedimentary and volcanic rocks since the Cretaceous. This is just a map showing the bedrock geology of the pebble deposit area. And as you can see, the Kaskenak batholith is a very big part of the bedrock geology in the mine study area. And the red circles outline the pebble deposit and other mineral showings in the area. So alteration, the rocks of the Pebble project have been subjected to several different types of alteration, and including all the ones that are listed there. And I'm not going to list them all. And here's just a map showing areas where those types of alteration are mostly found. Then the deposit structure. This is just a close-up map of what the deposit area looks like, and some of the local structures that you would see in that area. So there's 7 post-mineralization structures mapped in the deposit area itself, and most are normal faults which are currently inactive. And then I'll just put a diagram there of what a normal fault looks like. The primary large-scale structure in the Pebble West and Central Zone is a broad M-shaped anticline with fold axes plunging gently to the southeast. There's tertiary faults and shears evident in the drill core and from surface mapping in the area. And the displacement ranges from a few tens of meters to over 1.6 kilometers. And all these structures are currently thought to be inactive. The deposit geology mineralization is approximately 16 kilometers squared. The mineralogy and mineralization is typical of copper, gold, molybdenum, and porphyry systems, and is associated with potassic alteration and quartz veining in and around the upper parts of granodiorite stocks. The mineral assemblage includes pyrite, chalcopyrite, molybdenite, minor bornite, and tetrahedrite. And gold is mostly hosted by sulfide minerals in the deposit. And there's a rare skarn is also host to minor chalcopyrite in the area. And this is just a map of the deposit showing some of the exploration drill holes that have been done in the area. So there's quite a large number of drill holes that have been completed. The Pebble West Zone is composed of a Hornfels volcanosedimentary strata intruded by granodiorite and diorite sills and a multi-phase intrusive complex. It is dominantly calc silicate alteration and low-grade copper, gold, molybdenum mineralization. It's mineralized to at least 2,000 feet depth, and mostly deeper mineralization with a small but substantial zone of oxidation and shallow enrichment in Pebble West. And a leached zone overlies the shallow zone. In Pebble East, there's higher grade mineralization below the eastward thickening wedge of tertiary cover. The mineralization is related to intense calc-silicate and quartz pyrophyllite alteration extending to at least 6,400 feet depth. And on the eastern side, Pebble East is downdropped on normal faults, which found a northeast trending graben. The mineral resource estimate was last completed in 2009. Exploration drilling in 2010 and 2011 has mainly focused away from the resource, so it hasn't been updated since. The copper equivalent is a matter of expressing polymetallic deposits as a grade of the principal mineralization by value. The other metals are expressed as part of the copper grade based on estimated mineral prices for each metal. These values are not adjusted for metallurgical recovery until after metallurgical testing has been completed. As of 2009, the 43101 compliant mineral resource at the Pebble project at 0.3% copper equivalent was 5.942 billion tons of measured and indicated resource, grading 0.42% copper, 0.35 grams per ton gold, and 250 parts per million molybdenum, and 4.835 billion tons of inferred mineral resource, grading 0.24% copper, 0.26 grams per ton gold, and 215 parts per million molybdenum. There are other mineralized zones, as I mentioned before, around the project area, and I'll just briefly describe those. Near Sharp Mountain, there are small scattered quartz veins, which are highly anomalous grades for gold and silver. There's this, what's known as the Sill Zone, which is gold in several narrow, discontinuous quartz veins and strongly solidified breccia zones, again, gold and silver. The 001 Gold Zone, which is gold related to pyrite veins hosted by quartz or sericite pyrite alteration and lesser propylitic alteration. The 52 Porphyry Zone, which is anomalous copper and molybdenum in granodiorite with weak propylitic and calc-silicate alteration, or potassium silicate alteration. And the 38 Porphyry Zone, copper, gold, molybdenum, porphyry, associated with quartz sulfide veins and potassium silicate, propylitic, and quartz sericite pyrite alteration. And the 37 Skarn Zone, a strong skarn type, copper, gold mineralization in veins associated with calc-silicate alteration. The 25 Gold Zone, which is gold and copper concentrations in polymetallic veins, pyritic zones associated with quartz carbonate breccia, and strong chlorite epidote alteration in quartz veins. The 308 Porphyry Zone, which is copper, molybdenum, gold mineralization associated with potassium silicate and quartz sericite pyrite alteration cut by quartz sulfide veins. And the northeast Pebble IP anomaly, which is peripheral porphyry mineralization. And then there's the 65 Zone, which is characterized by a large area of strong hydrothermal alteration, including pyrite-rich potassium silicate assemblage, sericite, illite, and clay assemblages, and propylitic alteration. And the strongest mineralization is related to breccia bodies or stockworks of brecciated veins and fractures filled mostly by quartz and pyrite. There's a superficial geology study has been done at the project, including air photo interpretation of the area and extensive superficial geology by Hamilton and Cleforth, they included a review of all the available superficial geology data and test pits and shallow auger boreholes that had been done at the Pebble project. And a superficial geology map of the mine study area was produced by Hamilton and Cleforth in 2010. And this is the map that they produced. And the circle just shows the area of the Pebble deposit. The low-lying areas are covered with unconsolidated glacial deposits from 4 different episodes of glaciation. The Pleistocene ice moved southwestward down the Lake Clark structural trough and separated into 2 flows, which follow the present-day Chulhitna and New Halen drainages. and entered the area from the north and northeast. A second major glacier is thought to have flowed westward from Cook Inlet, expanding northward from the Iliamna Lake Basin. The glaciers blocked the three main drainages of the mine study area, the Upper Tulare Creek, North Fork Cockatoolie, and South Fork Cockatoolie rivers, at various times, and filled the drainages with ice-dammed lakes. The former glacier-dammed lake locations are bordered by beach and deltaic deposits. The superficial geology also includes arcuate end moraines, abundant kettle depressions, broad outwash aprons, elongate valley trains, and striking meltwater channels, which dominate the superficial geology of the mine study area. The superficial glacial deposits range from a few feet to hundreds of feet thick. Most are covered with typical tundra vegetation and organic soils, but some are exposed on the surface, as can be seen in this picture. The superficial organic soils are typically less than 30 centimeters thick and are often mixed with granular sand and gravel material. In many areas around the mine study area, rubble or bedrock rubble or felsenmeer formed by frost action covers many of the gently rounded hilltops and upland surfaces. And that is shown in that picture. There are solifluction lobes which initiate on the upper part of hills and pile up on the mid-slopes. And Holocene deposits fill the valley bottoms up to 160 feet deep and are locally covered by thin swampy deposits. And does anyone have any questions? Or do we just go on to the second?
Yeah.
Okay. There's a large glossary available on the website.